Alrighty, so today what we're going to do is we are going to come up with our own proof based on a statement. We're going to come up with our own proof based on a statement. And these three questions that I'm writing in every problem, what do we know to be true? What do we want to prove is true? What would a diagram look like? Those are not going to be questions that I ask you on the test. I just wrote those out because those are the questions you should be asking yourself when setting up your own proof based on a statement. So let's just jump right into this. It says set up a proof of the statement. Now this is nice because it just says set up a proof. Does it say set up then prove it? No, it just says set it up. So once you set it up, you're done. You don't have to prove it. Okay, sometimes I will ask you to set it up then prove it. Okay, set up a proof of the statement. If two altitudes of a triangle are congruent, then the triangle is isosceles. When the statement has the words if and then, it's really nice. When the words have the statement if and then, it's really nice because what goes with the if is what we know to be true. And what goes with the then is what we want to prove. So what goes with the if is what we know to be true, also would come out to be our given information, right? And what comes with the then is what we want to prove. All right, so these are the questions. I will not ask you these three questions on your quiz, but these are the questions anytime you're setting up your own proof these are the questions you want to ask yourself. So first question, what do we know to be true? Well, let's go back and read the statement. If two altitudes of a triangle are congruent, then the triangle is isosceles. Well, first question for you, what shape are we dealing with? James. A triangle. If two altitudes of a triangle, how many triangles are we dealing with? Just one triangle. So what do we know to be true? We know we're dealing with one triangle. Go back. If two altitudes of a triangle are congruent, what else do we know? This triangle has to have what in it? Chase. Two altitudes. So what do we know to be true? We know we have one triangle with two altitudes. So again, if two altitudes of a triangle are congruent, then the triangle is isosceles. What are we trying to prove? Aaron? You got it. What do we want to prove? We want to prove triangle is isosceles.
We don't have to put anything about the congruent part where it says are congruent.
Oh, I'm sorry. What do we know to be true? One triangle with two congruent altitudes. You're right. Thank you. What do we know to be true? We know we have one triangle and we know we have two congruent altitudes. Okay, now what would our diagram look like? Well, we know our diagram would be what shape? A triangle. We can name this triangle anything we want. I'm going to name it A, B, C. What does the triangle have to have in it? Two altitudes. Now, an altitude has to come from where? An altitude must start from where, Olivia? A vertex. So does it matter which two vertices we choose? It doesn't. It's our diagram. It's our proof. It's wherever we want. I'm going to go from A to D over here. And then I'll also go from C to E over here. Now, think back to when you were solving proofs. Whose job is it to mark up the diagram? with the given information? Is it the person who's creating the proof or the person who's solving the proof? Solving the proof. So are we marking anything here? No, we're not marking anything because it's not our job to mark it. We're creating the proof. Somebody else will solve it. All right, so we figured out what our diagram would look like. So now, based on this this diagram, we need to come up with the given information for the person that will solve it. So our given information, we can start out by naming our triangle if we want. So we're going to have triangle A, B, C. All right, what else do we have to declare for the person that's solving this proof? What else do we have to declare for the person that's solving this proof in order for them to prove it correctly? Bridget? You got it. So we're going to say CE and AD are altitudes. There's one more thing we have to give to the reader in this given information, something about CE and AD. There's one more thing we have to tell them. Caleb? That they're congruent. Because remember, it says one triangle with two congruent altitudes, right? So I'm going to say that CE is congruent to AD. All right, now what is it that we're trying to prove? What is it that we're trying to prove? Milo? You got it. So we're going to prove triangle ABC is isosceles. Not so bad, right? Right, we don't have to prove it because it just said set it up. It didn't say set up then prove. All right, next one. Set up a proof of the statement. The medians of a triangle are congruent if the triangle is equilateral. Well, what did I say comes with the word if, or what do we know about the word if? If the triangle is equilateral, that's part of our given, exactly. So what comes with if is what we know to be true, which is part of our given. All right, so this one's a little bit sneaky. So it says the medians of a triangle are congruent if the triangle is equilateral. So let's go step by step. What do we know to be true? What shape are we dealing with? A triangle. How many triangles?
One.
Just one triangle. So what do we know to be true? We know we have one triangle. The medians of the triangle are congruent if the triangle is equilateral. What about this triangle?
That's an equilateral.
Good. One triangle that is equilateral. What has to be in this triangle? The medians of a triangle are congruent if the triangle is equilateral. What has to be in this triangle? The medians of a triangle are congruent if the triangle is equilateral. Looking for somebody new to have a thought. Looking for somebody new. Mariana?
Medians.
Medians. All right, a triangle has how many medians? 3. A triangle has 3 medians. And see how they're pluralizing it? The medians of a triangle are congruent. So that means they're talking about all the medians. So a triangle that is equilateral, and then we also know we have 3 medians because it pluralized it. The medians of the triangle. The medians of the triangle are congruent if the triangle is equilateral. Now, what do we want to prove is true?
The medians are congruent.
We want to prove the medians are congruent. So what do we want to prove true? Congruent medians. All right, let's come up with our diagram. So again, we're dealing with one triangle. So I'm going to draw my triangle. I'm going to call this triangle once again ABC. And now what must we draw in this triangle? What must we draw in this triangle? Aaron? I'm sorry? No, that is not our job. So the person that's solving the proof would mark everything congruent. But there's still something I need to draw in this diagram for the person to be able to solve it. Yeah. The medians, good. And a median has to come from where? A vertex. So I'm drawing in three of the medians, or all three of the medians. So I'm going to go from A to D, from C to E, and from B to F. Is it my job to mark anything congruent? It is not my job to mark anything congruent. The person who solves this will mark it all congruent. All right, so now we have our diagram. So now we need to come up with our given. Well, our given is going to be based on what we know to be true. So what do we know? We know we have one triangle that is equilateral. So what do I have to tell the reader in the given information? Chase?
Triangle ABC is equilateral.
You got it. So we're going to start off by saying triangle ABC is equilateral. There's one more thing I have to tell the reader. Milo. Excellent. We have to tell the reader that we have the medians. So we're going to name our medians. We're going to say AD, CE, and BF are medians. And now we need to prove that the medians are congruent. So which segments are we trying to prove congruent? Olivia? You got it. So we're going to want to prove that AD is congruent to CE, which is congruent to BF. Right, we just had to set it up. We do not have to prove it. Can we go on to number 3? Okay. So this one is a little bit more difficult because there's no if, there's no then. Right? It says the altitude to the base of an isosceles triangle bisects the vertex angle. The altitude to the base of an isosceles triangle bisects the vertex angle. All right. I'm going to go a little backwards here. Do we agree it says the altitude to the base of an isosceles triangle bisects the vertex angle? We're trying to prove that the altitude bisects the vertex angle. Can we all agree on that? The altitude, this is a statement. We're going to have to prove this statement. The altitude to the base of an isosceles triangle bisects the vertex angle. So what are we trying to prove? Altitude bisects vertex angle. So now let's go backwards. So now we figured we know that's what we want to prove by sort of how the statement is laid out. Now we're going to go back and see what we know to be true. Well, it says the altitude to the base of an isosceles triangle. Therefore, what kind of triangle are we dealing with? It says the altitude to the base of an isosceles triangle. So an isosceles triangle. So I'm going to have one isosceles triangle. And it says the altitude to the base of an isosceles triangle bisects the vertex angle. What has to be in this triangle? Chase.
A base and legs.
Yep, that goes with isosceles. You're right. But it says the altitude to the base of the isosceles triangle bisects the vertex angle. So what is doing the bisecting here? Olivia? The altitude. It says the altitude to the base of an isosceles triangle. That means that isosceles triangle has to have an altitude in it, right? So one isosceles triangle, one altitude. All right, so now let's come up with what this diagram would look like. Well, we know we're dealing with just one triangle. So here's my triangle. I'll call this triangle once again ABC. What must I draw in this triangle? Same hands every time. Connor.
One of the vertices you have to draw an altitude.
Exactly. So I need to draw an altitude. I'm going to start at B. I'm going to go to the C and I'll call AC and I'm going to call that point D. Is it our job to mark anything? It is not our job to mark anything. So now we have an isosceles triangle. We drew in an altitude. We're good with our diagram, right? So now we have to come up with our given information. Now, in the given information, do we all agree we have to tell the reader that triangle ABC is isosceles? Right. But remember, when we were proof solving, when we were the ones solving the proof, we needed extra information. We couldn't just know that it was isosceles. Why couldn't we just know that it was isosceles? James. Good. We have to know the base or the legs or the vertex angle, something to let us know which sides are congruent, right? So the way we're going to write this is we're going to say triangle ABC is isosceles. And then in parentheses, guess what I'm going to write? Base AC. Does that allow the reader to now figure out which two sides are congruent? Yeah. Right. There's one more thing in the given information that I have to declare to the reader. What are we going to tell them? Emily? You got it. We're going to say BD is an altitude. And now we want to prove that the altitude bisects the vertex angle. Well, in this diagram, we know BD is the altitude. Which angle is the vertex angle? Name it with 3 letters. Which angle is the vertex angle? Mila. ABC. So what we're going to prove, we need to prove that BD bisects angle ABC. The altitude bisects the vertex angle. All right, I want you to try this next one on your own, number 4. We're just setting up the proof. We're not solving it, and we don't have to worry about this independent problem. Who wants more time? All right, so let's see this. If two angles of one triangle are congruent to two angles of another triangle, the remaining pair of angles are congruent. All right, so I'm going with the word if. If is what we know to be true, aka our given information, right? So if two angles of one triangle are congruent to two angles of another triangle, how many triangles are we dealing with this time, James? Two. We're dealing with two triangles. All right, what else? If if two angles of one triangle are congruent to two angles of another triangle. Connor.
That two angles in one triangle are congruent to another two angles of another triangle.
You got it. Two angles in one triangle congruent to two angles in a second triangle. All right, what do we want to prove is true? Chase?
The remaining angles are congruent.
Good. Third pair of angles congruent.
Another question. So,
Yeah.
for the first part, what do we know to be true? Could I say two triangles with two congruent angles?
Absolutely. So this whole part doesn't matter. So on the test, all I'm going to care about is your diagram, your given information, and your proof statement. All these questions will not be there. That's just for you to organize things in your head. But for the test or the quiz, I'm going to say, here's the statement, draw the diagram, give me the given information, give me the proof statement. All right, so what does this diagram look like? Well, do we agree this diagram is going to look like two triangles? We're going to have A, B, C, and then we'll have D, E, F. All right. Could you have drawn it like this if you wanted to? If you wanted to, you could have. It doesn't matter. How many people drew them separate? Okay, so we'll go that route. So now we're given that we have triangles, so you could declare that you have triangles. So you could say triangle ABC, comma, triangle DEF. And then we have to tell the reader that two pairs of angles are congruent. So I'm going to go ahead and I'm going to say angle A is congruent to angle D. What else can I say? Olivia. You got it. Angle C congruent to angle F. So yours might not look exactly like mine, right? Because you could have chose different letters. You could have chose different angles congruent. As long as you have that idea that you pick two angles from one triangle congruent to two angles of another. And what is it that we want to prove? That the last pair are congruent. So, oh, Sophia, your hand wasn't up. Well, you can do it. Look at our diagram. We said A is congruent to D, C is congruent to F, so we need the last pair of angles congruent, which will be? You got it. We want to prove angle B is congruent to angle E. All right, so that's the end of this lesson.